How to analyze non-normal distributions? When data is normally distributed, the cause for non-normality should be determined and appropriate remedial action should be taken. Causes: extreme values. Too many extreme values in a data set will result in a skewed distribution. Find measurement errors and remove outliers with valid reasons. Overlap of two processes. See if it looks bimodal and stratify the data. Insufficient data discrimination. Insufficient data description. Round of errors or measurements devices with poor resolution makes data look discrete and not normal. Use more accurate measurement systems or collecting more data. Sorted data, if it represents simply a subset of the total output a process produced. It can happen if the data is collected and analyzed after the sorting. Values close to zero or a natural limit. The data will skew. All the data can be raised or transformed to a certain experiment, but uh, we need to be sure that a normal distribution can be assumed. Data follows a different distribution. Gaussian distribution, rare events. Exponential distribution, factorial growth. Log normal distribution to length data. Binomial distribution, proportion data such as present defectives. Data follows different distribution. It is very important. Equivalent tools for non-normally distributed data. Equivalence tools for non-normally distributed data. For t-test, ANOVA, median test, Kruskal-Wallis test. Paired t-test, one sample sign test. How do how do you test a data sample to see whether it is normally distributed? I would I would first plot the frequencies comparing the histogram of the sample to a normal probability curve. This might be hard to see if the sample is small. In that case, we can regress the data against the quantities of a normal distribution with the same mean and variance as the sample. The lack of fit to the regression line suggests a departure from normality. Another thing you can do a back of the envelope calculations is taking samples maximum and minimum compute the Z score or more properly the the t t statistics, which is the number of sample standard deviations that the sample is above or below the mean. Here and the compares it to the 68, 95, 99.7 rule. Here SC Z equal to x minus x bar. This is expected value, finded value. Then divided by S divided by root of n. Then we have to divide. Then we got the Z result. If we have a 3 sigma event and fewer than 300 samples or a 4 sigma event and fewer than 15k samples, then a normal distribution understates the maximum magnitude of the deviations in the data. For example, 6 sigmas events don't happen in normal distribution. Six sigmas don't happen in a normal distribution. What is a Hermitian matrix? What is important property does a Hermitian matrix eigenvalues? It is equal to its conjugate transpose. For example, Paul matrix. A real matrix is Hermitian if it is symmetric. The entries in the main diagonal are real. Any Hermitian matrix can be diagonalized by a unitary matrix U U U into U equal to I, and all the eigenvalues are real matrix as n linearly independent eigenvectors. A random variable x is distributed as n of a comma b, and the random variables y is distributed as n of c comma d. What is the distribution of 1 x plus y, 2 x minus y, x into y, and x bar y? N equal to mu n of mu comma sigma equal to 1 by n of mu comma sigma equal to 1 by sigma of root of 2 e power minus of x minus mu whole square divided by 2 sigma square are the standard normal distribution described by the probability density function. Probability density function, this is the formula. Here in n of mu comma sigma equal to, we have to take 1 from sigma root to 2 to be reduce scaling, then multiply with sigma, then into multiply then multiply with e power x minus mu whole square. Mu subtract from x, then to be square. This value divided with 2 sigma square. Sigma here multiplying 2 times of sigma square. Here 2 square rooting. Then here, sorry, this side negative, this side only negative, this side positive, no? E power, e minus here only. So, for example, this is exactly this square. Okay. So, standard normal distribution described by the probability density function. Phi of x equal to 1 by 2 by e power e power minus 1 by 2 x square. Here 2 by rooting, then take one value like this, then multiply with e power 1 by 2 x square, x to be multiplied x square, x squaring, then multiply with half 0.5 in negative side, then multiply with this. Z infinity approximately equal to n of mu x sigma square x. Y say approximately n of mu y sigma square y. Now by convolution, we see that the Fourier transform is a Gaussian PDF with z equal to x plus y approximately equal to n of mu x plus mu y, comma sigma square sigma x square plus sigma y square, sigma square y. You can say this is the x side, this is y side, this is also y side, this is mu x side and y side. Okay, sigma sigma x mu. Okay, this is x side, y direction. Then here also sigma mu. Okay, multiply with the total area. It is equal to x plus y. That is the Gaussian medium. Requires the assumptions of independence if requires of assumptions of independence. Assumption of independence from independence. If the random variables are correlated, the joined random variables are still normally distributed. However, their variances are not additive, and we need to calculate the correlation. Any linear combination of independent normal deviates is a normal deviate. Any linear combination of any combination of independent normal uh, deviates is a normal deviate. Is a normal deviate. Okay. The product of two Gaussian PDFs is proportional to Gaussian PDF. The product of two PDF is proportional to Gaussian PDF if we mean to Gaussian PDF proportional to Gaussian PDF if we mean that is half of the coefficient of x and SE, that is square root of half of the denominator, square root of the half of the denominator, mu xy square root total value reducing, it means here. So sigma square x sigma square y. Okay, here x sigma squaring x side y side, the both are multiplying. Okay, this one. Then here addition. Here if you multiply higher value, then addition, then divide. That is here sigma xy. Got it. Okay, xy total x. And see mu xy equal to mu x sigma square y plus mu y sigma square x, divide sigma square x plus sigma square y. Okay, how to write a competitive analysis? How to write a competitive analysis? Your company competitors, list of your company competitors. List of your company competitors. List of your company competitors. Companies that indirectly compete with yours, ones that you offer products or services that are aiming for the same customer capital. Competitor product summaries. Analyze the competition products and services in terms of features, value, and targets. Features, value, and targets. How do your competitors sell their wares? How do they market them? Customer satisfaction surveys conducted. How do customers see your competition? Competitor strengths and weakness. Be objective, no bias. What makes their product so great? If they are growing rapidly, what is about their product or service? What is promoting that growth? The market outlook. What is the market for your company's product like now? It is growing. If so, then there are likely quite few customers